Hi, everyone. In the previous session, still in the chapter 6, in the previous session, we explained how to solve graphically simultaneous equations. But it is not always the case of drawing and taking it time. So we need practical methods. And the most practical method is to solve algebraically simultaneous equations. How to solve in algebraic way, given the given simultaneous equations. So we should know that we can find our solution by substitution or by elimination. So we are going to start with solution by substitution. So first of all, we find one variable in terms of the other from one of the given equation, because we have two simultaneous equations. We have two equations, and we should use one equation to find one variable in terms of the other. Then we substitute the obtained variable into the other equation. We use what we find into as a variable in terms of the other variable, and we substitute it in the second variable. Okay, like we are integrating the two equations in the one equation. So we obtain a reduced equation with one variable. We obtain a linear equation and we solve it. We solve the reduced equation to obtain one. We obtain one of the variable. Of course, we will substitute the value of the variable that we obtained in the first equation, to obtain the value of the second value. How? So normally we have here ready y equal to 2x plus 3. So we have a one variable in terms of the other variable. We have a y as the subject. So we can use to substitute 2x plus 3 for y in the second one. So we replace y by 2x plus 3. Okay, so normally when we substitute it, we will obtain this equation, and we expand the bracket to obtain easily, when we combine the like terms, we obtain easily minus 5x minus 12 equal to 8 as reduced linear equation with one variable, easy to solve. We'll obtain finally the solution x equal to minus 4. Okay, this solution is not the simultaneous solution, because we know that the simultaneous solution is a couple of x and y, two values, x and y. So we take this value and we substitute it in the second equation. And the second equation, we replace x by in the first equation, because we use the second equation at the base of our integration, okay, of our substitution. So we use again the first equation, and we substitute minus 4 for x in the first equation, so to obtain y equal to minus 5. Normally, the simultaneous solution is x equal to minus 4 and y equal to minus 5. Easily here, we have a y equal. So normally, if we substitute, we have a y ready in terms of the second equation. So we substitute 3x minus 5. For y in the second equation, like we are saying, 3x minus 5 equal to 10 minus 2x, because we have a y equal, we can easily get rid of this y and take these values as equal terms. So 3x minus 5 equal to 10 minus 10x to obtain this one, and easily to go further to solve this equation by having the variables in the same side of the equal and the constant in the other side of the equal, and we solve it to obtain y equal to 4. When y equal to 4, we substitute 4 for y in the first equation, and we will obtain 4 equal, for example, x equal to 3, and we substitute 3 for x in the first equation to obtain y equal to 4, and we go properly to find the solution, the simultaneous solution with the couples 3 and 4. Okay, so it is easy also to have the same, to follow the same steps as we see here clearly. We have first equation, we have a second equation, we have a y equal to 2x minus 7 ready to be substituted in the second one, and we go to find, for example, x, and then we substitute the x value that we obtain in the first equation to obtain y. So normally our simultaneous solution is the couple 3 minus 1. And also for solving we can solve the following pairs of simultaneous equation as direct applications of what we explained before, and easy to find that the simultaneous equation is a couple of two values, x and y. Okay, what about solution by elimination? How to solve by another method? We have two ways of solving algebraically simultaneous equations are by substitution, by elimination. By elimination, we should have, if we make the coefficient of one of the variables equal in size but opposite in sign, we can add these terms. We can add the equations. Okay, so we combine like terms. For example, here in this one, okay, we have a 3x, 5x, 2y, minus 2, 27. Normally, it is very easy to see clearly that it is the simplest form, the simplest way to make the coefficients of one variable. We choose y because it is easier than x. To have the same coefficient, because if we multiply the second equation by 2, we will obtain 10x minus 2y equal to 27 by 2 for 52. So the second equation will remain, the first equation remain the same. The second equation becomes 10x minus 2y equal to 554. And then by adding them, we eliminate the y value, the y polynomial with y. Okay, to obtain 13x, we combine the like terms to obtain 13x equal to minus 2 plus 54 equal to 52. Then easily we find x equal to 4. When we find one of the variable, we substitute it in the first one or in the second one, and not like the way the solution by substitution. Okay, then we will obtain minus 7, and you know the simultaneous equation is a couple of 4 minus 7 in this case. Okay, but we should know in this case only one equation had to be changed to be able to eliminate one variable. Often both equations must be multiplied by different numbers, but as I said before, in general both equations must be multiplied by different numbers to be able to eliminate the variable. So yes, we should keep in mind this important and crucial information. We should note that when we multiply an equation by a constant, so we multiply each term of them. So 5 by 5, 25x. Minus 1 by 5, it is minus 5y. 2 by 5 equal to 10. And normally when we multiply it by minus 1, so minus 2 minus 1 it is a 2, plus 5 by minus 1 minus 5y, minus 1 it is a 1. Okay, because we should get ready and prepare ourselves to solve by elimination. Normally when we want to add these two equations, so it is the story of like terms, combining like term. 3x plus minus 3x, it is a 0x, minus y plus 4y, it is a 3y, and 4 plus 2, it is a 6. So normally 3y equal to 6. So easy to complete from this step, from this level to find the simultaneous solution. Okay. Finally, we have a simultaneous equation and we want to solve it using elimination method. So in this, for example, in this one, we can remark clearly that we have the same coefficients with the same values, but opposite signs. So we simply add it to get rid of one of the variable. So to eliminate one of the variable, 2x plus 3x is equal to 5x, minus y plus y equal to 0y, and 8 plus 7 equal to 15, and we complete our way to find the other variable, the value of the second variable. But in this case, we have a 2x, we have an x in the second one, we have a y, we have a plus 3y in the second one. So we have we have no relations between coefficients of the two equations and the two variables. So we need to multiply one of equation of the or both equation. So it is easy here because one of the variables here they have as a coefficient has a unit as a coefficient. So we multiply it by, for example, by 3 or by -3 to add it simply. If we multiply the first one by 3, so we'll obtain 3y here and the 3y here. So we should subtract the two equations. So to go away and to avoid any mistake by subtracting, so we multiply by the same coefficient and with the opposite sign to add these two equations. So we obtain, as I say, we see here clearly -6x minus 3y equal to -3. We add it, we obtain one of the value, and we substitute one in one of the following equations to obtain our the value of the second variable. These are the crucial information of this section. Thank you for listening. Have a nice day.